Welcome to this special talk by Wendy Ju. I wanted to give a quick intro. Wendy has earned her bachelor's in mechanical engineering from Stanford, master's in media arts and sciences from MIT, Ph.D. in design in mechanical engineering from Stanford. She's currently an executive director at Stanford's Center for Design Research. She's also an associate professor in interaction design at CCA. Wendy's work has been internationally recognized. Wendy's uses clever design and methodology to study how humans interact with autonomous systems, from automatic doors to autonomous self-driving cars. Wendy and her team has pioneered protocols to study how humans interact with autonomous cars on the roads, which we will hear more about today. Wendy is also a popular professor teaching interaction design to design students at CCA as well as engineering students at Stanford. I'm super excited to have Wendy today. Please welcome Wendy.
So as Kamiko mentioned, I'm an interaction design researcher. And what I'm really interested in is doing research to understand how we're going to interact with systems in the future. One of the things I think is going to be an important aspect of interaction design is how we're going to interact with autonomous systems. And I'm focusing today's talk, just on the research I've done in the space of autonomous vehicles. I'll show you some of the work I've done in human-robot interactions just by way of introduction. But I think that the work that we're doing in the vehicle shows kind of the range of things that we're doing for research. And I kind of divided the talk into three phases, showing some of the work that we've done in simulation experiments, looking at some of the things we've done to instrument and measure interaction, and then finally showcasing some of the work that I think is really fundamental that we're doing, where we do open-ended design experiments, which I think is the font from which we derive many of our design hypotheses and experiments from. And so the title of this talk is called Theater of the Car, because a lot of what we're doing is a form of theater. We're basically showcasing things that might happen in the future and understanding how people will behave in those situations and using that as a way of kind of generating information about how we should design systems, what the likely result of those things will be, and helping us think about what these issues are going to be in the future when we have more autonomous systems like cars, but also other things, doors, environments, desks, tables, chairs. So the kind of research methods I use are often described as novel, eclectic, weird. And I want to say that the reason why we do the research the way that we do it is because one of the central challenges for designing interactions in the future is overcoming the limitations of the present. What you really want to do is be able to grab a little piece of the future, understand what might be, and think about if that's what you intend as a desired future. And so one of the things we do is we basically stage future environments, but then use present-day people to understand what that future might be like. And I know that sounds crazy, it doesn't make perfect sense, so I'm going to show you two videos from my human-robot interaction research, just by way of example. So this first project, which was done with my then Ph.D. student, and then Brian Mock and Stephen Yang, looking at how people are going to interact with a mechanical ottoman. So you can see, so just to explain it by way of background, that these interactions are actually being piloted by a person who's in the next room. They have a remote control. They're able to like operate the ottoman, and that person has the same view that we're seeing of the scene that's going on. And that person is given the high-level directive to both engage the person, try to get people to put their feet up on them, and then 2 minutes later to disengage, you know, and leave. And none of the people in this experiment actually knew that there was going to be a robot coming. I will say they are waiting there after another experiment. We told them we're setting some stuff up in the next room, and just to wait here, you can read a magazine or use an iPad, and we'll come get you when we're ready. And then this happens. You know, that we are using a wizard because the kind of interactions we expect are contingent behaviors. So the right thing for the wizard to do at any point in time depends on what the user does and how the user reacts. And then we basically, the person's given this high-level directive, but you know, is actually meant to improvise the right response. And in our experiments, what the wizard chooses to do in reaction to the user is as much a part of the experiment. I don't know what happened over there. Is as much a part of the experiment as what the user is doing. And one of the things that's also really interesting as a design experiment is that we're not necessarily trying to get everyone to do the same thing. We're trying to elicit the range of responses that people might have so that we might understand those things better. And also the interesting things come out. I mean, one thing that's interesting is a confirmation of Cliff Nass's computers as social actors hypothesis, that people treat the machine socially. Very often when the machine leaves, people think there's someone more important in the next room, you know, maybe it has somewhere to go. So now it's like the ottoman, but it has an agenda and a sense of social status. The other thing that's interesting is sometimes if the people weren't willing to put their feet up on it, they were worried that the ottoman was a bit offended. So they really understood what the ottoman wanted, and then there was this discussion when we were interviewing them afterwards, like, well, it seems like a dog, and I wouldn't put my feet on a dog. I wouldn't want to trap it. But they knew even as they weren't putting their feet on it that they were concerned about the feelings of the ottoman. So those are some really interesting things that can come out of this sort of open-ended experiment that we run. Here's another example of this kind of experiment, but this takes place not in a lab, but in a field setting. And this looks at how people interact with a robot trash barrel. So in these kinds of experiments, we're really trying to understand how we're going to design future interactions. And one of the core goals that we have is trying to elicit all the things that might matter. One of my favorite quotes about design and design thinking comes from Bill Moggridge, and he says that design, by definition, is mostly tacit knowledge. It has to do with people's intuitions and harnessing the subconscious of the mind rather than just the conscious. And so a lot of what we're doing when we're doing the experiments is to understand all the things that might matter that are not immediately obvious if you only think about it. So we're basically working with people to co-construct the future and then trying to understand the things that might matter. For example, when you're trying to engage people, people actually know how to direct their attention in ways that are real and then performed. And so if someone sees a robot coming through, but they have other things to do, they perform in attention. And that's actually something that's incredibly difficult for a machine to understand, like the difference between real and attention, whereupon you might want to make sure you're seen so you can see if someone's interested in interacting with you, and performed in attention, in which you should respect, and shy away from. So these are distinctions that we make in our everyday interactions with one another that govern when we choose to engage and disengage with people, that is incredibly difficult to teach to a machine, but at least it's important to know that it's there and what it looks like. In some ways, I think of this work as kind of a grand challenge in the space of AI, and it's really that interaction is one of the hardest things that we do as people and will be very hard to do with machines. I really like this quote from Hans Moravec, and people often quote this when they talk about Moravec's paradox, where he says it's comparatively easy to make computers exhibit adult-level performance on intelligence tests or playing checkers, and difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. And I would actually put at the end of that, interaction. Interaction is something we do every day, and we do it so easily that we don't even think about it. Just how we walk through doors without running into each other. And this is something that's very, very difficult for machines to understand, and very, very difficult for us as technologists and engineers to design in, because it's invisible to us and because we take it for granted. And so being able to elicit how these things work is a crucial step to making good interaction happen. So one of the things that we do in our research is think about the methods that allow us to kind of elicit these situations and develop understandings. And simulations are very helpful for that. And I really like working in the automotive space, in part because it's a community of people who already believe in simulation, understand the role of simulation, and testing futures. And so in our automotive research, a lot of our experiments happen in something like this. This is the Stanford driving simulator. It's a whole car chassis, and it's surrounded by a big 270-degree screen. And it's actually really amazing because it's this whole theater that's set up for one person who sits in the driving seat. And that person also has, little screens for the dashboard and for the side mirrors, and when they another screen in the back for a rearview mirror. But where there would normally be an engine, there's actually a bunch of computers and sensors and cables collecting all this camera data of showing what's going on when people are in these driving experiments. And so I'm going to show some examples of experiments that we're doing that are controlled experiments in the automotive simulation space. And we're looking at interaction with automation. So a normal experiment that we might run might be kind of a 2x2 traditional media studies problem. So we'll basically pick 2 dimensions that we think are going to matter in an interaction. In this case, the driving style, whether it's kind of perfect driving, something that takes dead center lock in the middle of the road, or imperfect driving, a car that doesn't necessarily violate any laws, but weaves around the way that people do within the lane, cuts corners a little bit. And then sometimes we'll do something like change the user interface. So we'll have a steering wheel where you either have to directly, you have to press a button, explicitly perform takeover. It's my turn to drive. Now it's your turn to drive, Or we'll do something where we allow more implicit transitions, where anytime you grab the steering wheel, the car gives you control and allows you to influence the driving. And in our experiment, we did actually influence plus takeover. So you can both explicitly or implicitly take over the car. And so when we run these experiments, we usually make sure we have at least 12 people per condition, or 10. And so, we're measuring things like how often in a driving experiment, if your people are given these different scenarios with perfect and imperfect driving, implicit versus explicit takeover, how often do people intervene? They're just given the chance to if they want to, if something comes up. And then how much of the time, overall time, do they intervene? Do they actually choose to intervene by pressing the button or grabbing on in the implicit plus explicit state? And then what are the subjective ratings people have of the car? And one of the interesting results that we have from these kind of studies is that we find out that people, of course, are more likely to intervene when the car is driving imperfectly. They'll just like reach out and kind of, center the car a little bit. And the people who have the chance to intervene by doing implicit actions were much more likely to jump in and correct the car than something where you have to do explicit handover. And this is a really interesting result because what the automotive companies would really like is to have really clear delineations of control. Like it's absolutely clear whether it's the car is supposed to be responsible for a situation or it's the driver that's supposed to be responsible for the situation. But what we find is that drivers are much more willing to correct the car and like sort out little different things if you make that transition muddier. They really like to give the car input on its driving. They like to, and even the people who are in the explicit condition were all the time moving the steering around even though it had no effect. And so that's like a really interesting thing to say. Like I think a lot of people assume that if you design things a certain way, you can enforce a certain kind of behavior. But what we find is people do what comes naturally, and then like things come out the way they do. The other thing that's interesting is we often start our studies by running the experiments with college-age students because that's we have on a college campus. We have many college-age students, and more importantly, they are smart. They show up on time. They read all the questions. They fill things out. And so, if you can't run an experiment with college-age students, that experiment is not going to work with any other population. But once you actually have a well-validated study, you can actually take that same study design and use it with other populations. So we did a follow-up study where we did the same study, but we actually had older and younger drivers. And because we found that the perfect driving condition wasn't the thing that varied that much, we actually just used the demographic as the thing that we were varying instead, and then looked at how often people intervene with the imperfect driving. And one of the really interesting things here is that older drivers, though they were actually much more skeptical of the automation and might not want an autonomous car, really like driving fine, when they were actually in the car, watching the car do different things that were imperfect, they were much less likely to intervene than new drivers or regular drivers. They kind of behaved the same. Why is that? It turns out older drivers have a lower opinion of their own driving capability. And so even though they see the car's not doing perfect, maybe the car's doing pretty well compared to how they're going to do. And so that's like a really interesting thing, that the behavior of drivers is actually going to be relative to people's own estimation. And I will say, actually, in these experiments we had, because it was voluntary and people could switch between manual and autonomous driving, we also have data of how some of the older drivers drive. And they have much slower reaction times, and they sometimes don't see some of the things that are going on inside the road, but they do a lot to compensate for that. So they actually maintain twice the headway distance of younger drivers and things like that. So that, if you actually look at the accident rates for older drivers, they're not higher than for younger drivers, but the way that they drive is really, really different. Another kind of experiment that we run will be a structured transition experiment. So unlike the previous experiment where people can but don't have to transition to automation, in this kind of experiment, we actually tell people that you have to go into autonomous driving mode, and then tell people at different points in time that they have to switch out of autonomous driving mode. So this is a timeline of what a typical structured transition experiment might be. We will actually start out by having people drive the car manually just to get used to the driving simulator, and then we'll perform autonomous driving for about a minute just so people get a feeling for what that's like. And then for the rest of the experiment, we actually will, when you're on the freeway, ask people to switch into autonomous driving. And then if you're merging off of the freeway, or if there's road construction or something, or some interesting merge, we might tell people they have to switch out of automation. And they're given, the required amount of time. I think it's actually 30 seconds is the NHTSA recommended alert. And then shortly after the transition, we have things like car cutoffs or pedestrian incursions, and we use that to test how well people manage to drive after they switch from autonomous to manual driving. So in this kind of experiment, we're looking at, we're comparing how people do if there's different kinds of automation, if they're just doing manual driving the whole time as a control, or if there's just lane keeping or ACC, or basically in the automotive term, they say longitudinal or latitudinal or both automation. And then we look at how well people do after the transition, what the takeover time is, but also what the steering wheel deviation is, what the road offset is from the steering line, their own subjective self-rating, and event performance. And one of the reasons why we have to have this many measures, and this is something that I think it was a new discovery to me when I started doing automotive research, people are really good at driving. You can set people up into like near impossible situations, and they actually perform shockingly well. And actually, this makes sense for a lot of people in the U.S. Like driving might be the maybe next to writing or doing text messages. Driving might be the skill that they have actually dedicated the most part of their life to doing well at. And so it's actually, you have to make pretty difficult and fairly contrived situations to get performance differences, because people are really up to overcoming the challenges of many driving situations. So you have to look at these secondary measures, like how much the steering wheel deviates or what the road offset is, just to even tell that something's wrong. And we get pushback from people. They're like, but it's not really bad if the steering wheel is deviating. We're like, no, but that is just the thing that we can see is different when we are doing these pretty hardcore manipulations. And one of the reasons why I'm telling you about this, that people are really good at driving and it's really hard to get performance differences, is that then you can understand that when we get performance differences that are big, like it is a really big deal. So the second experiment I want to tell you about on the right, the title gives away the punchline. And the punchline is that distraction becomes engagement in autonomous driving. So in this experiment that we've run, and I really think that this is something I'm going to put in Science magazine, we actually had people, when they were in the autonomous driving mode, watching a movie on the iPad, reading, actually Peter Pan, on an iPad, or supervising the autonomous driving. And we also changed different aspects of the interface, whether the transition message was happening just on the dash versus on the dash and the iPad, and then whether they're given like 2 stages of warning or just like 1 warning in the transition. And this is kind of bearing the lead. Supervising ADAS causes sleepy behaviors. So it turns out that when people are supervising automation, and only when they're supervising automation, they get sleepy. It looks like this. This is really amazing. People are only in autonomous driving. You saw my earlier timeline. They're in autonomous driving mode for 8 minutes at a time. They are not at home. It is granted a little bit dark, but we're not recruiting people from some sort of like sleep center. And then look at these results. This is a within subject study, so it's the same people in all the different conditions. They're just driving these different conditions in different order. We randomize the order. But you see when people are supervising the car, and only when they're supervising the car, they are passing out in the car. So this is out of 48 participants, this is like 26 people like falling asleep. And when people are watching video and reading passages, that's not happening. And this is when either people are yawning or they're closing their eyes for longer than 5 seconds is what we classified as sleepy behavior. So why is this important? Nobody is talking about, everyone's talking about autonomous driving like it's this big, exciting future. It is boring. It will make people fall asleep. And if we are counting on people to be able to take over and compensate for the car, like we actually have to actively keep them awake. So some people are saying you just can't count on people. We have to go straight from manual driving to full automation because people are totally unreliable. But look at these other 2 bar graphs. It is actually possible to keep people awake. The thing that we had people reading was Peter Pan. It is not like bodice ripping material. It's just Peter Pan, and that keeps people awake. And it also tells us something interesting. So first of all, autonomous driving is really, really different than manual driving, because in autonomous driving, the main thing the car needs to do is keep people alert. It's a totally different paradigm than what we think about in manual driving. But it also says something interesting and weird about what's currently going on. Distraction is the thing that most people who are doing car research are working on right now. They're trying to keep people from doing distraction activities. Why are people calling on the phone? Why are people playing Pokemon Go? This research suggests that maybe people are doing it as a way of compensating for being sleepy. Like I have had people tell me all sorts of crazy things they do after I show them the results. Someone told me that she watches a cooking show on 280, when she commutes. But you can see that like autonomous driving is actually a really, really different thing than manual driving. And then here's the other thing that's the crazy follow-up, like weirder punchline to this. People who are asleep, they are sleeping, we give them like a warning, like, you're gonna have to take over. They wake up and they take over control and they do fine. Go back to this. There's no major differences in their performance after that. So when I say people are really good at driving, people are like really good at driving. And these kinds of accidents that happen, like with the Tesla accidents, they're the sorts of things that you're only going to be able to detect in a study that you can actually run on the road, where you're actually getting like hundreds of thousands of miles. Because people are so good at driving, they can wake up from a stone cold sleep, they'll be snoring, they will get up and they will like steer a car. So it's bad, but it's going to be really hard to do the experiments to understand that just in the driving simulator like we're doing. The last kind of experiment we run are looking at unstructured transitions. So unlike that study that I was showing you before, where you're given a decent amount of warning, in these experiments, we just basically say, emergency, automation off. And then turn off the automation, then we see how well people perform. And we'll have something like a turn in the road, so that if you don't react, you basically go shooting off the road. And we basically do that unstructured transition 2, 5, or 8 seconds before that turn. This is something that will never happen in a real autonomous car. It's actually not a future that we perceive. But one of the things that when people ask, like, when will we start having autonomous cars? One of the things that's a big limitation is how far into the future does the car need to be able to predict what's going to happen? If that answer is like 2 to 5 seconds, then you can actually do a lot of the computing on board with a lot of the existing technology, and it wouldn't be too expensive. If the thing is 8 or 10 or 30 seconds, what you actually need to be able to do on board without any information from the cloud, will be far more. And that could actually be something that delays the onset of real on-road automation like 10 years. And so these are questions that people in the industry are really interested in, even though it's not a representation of something that's going to happen. So one of these things that's super interesting is that I'm just showing graphs from 3 different studies where we did unstructured transition. And you can see that most people, if they're doing nothing but supervising the car, and these experiments are only 15 minutes long, so people are less likely to be sleepy, that only in the 2-second condition do you actually see people doing poorly. And again, poorly means we're measuring things like road offset and steering wheel deviation, because most people manage to stay on the road. So in the 5-second condition and 8-second condition, people are actually doing a pretty good job driving that turn. And there's actually it's a little bit of a floor effect, but there's no real difference between the 5 and 8-second condition. And what we see when we watch the video is that if people can't visually verify what the car is asking to do, they don't do anything else to prepare. So that extra lead time that you're giving them, unless you tell them exactly what they're supposed to be doing, it doesn't do you any good. When we give people a passive secondary task, so that's something more like watching a movie on an iPad, people still, they do really poorly in the 2-second condition, but they're still like in 5 and 8-second conditions doing pretty well. And this is, a lot of what's bad about the 2-second condition is if people are watching a movie and the car says emergency automation off, people will try to stop the movie and put down the iPad before they take over. So what we would expect is if you were running something with a heads-up display or something like that, you wouldn't actually even see this much. In this active secondary task condition, we actually had people playing Temple Run. Have you guys played Temple Run? It's this game which is a first-person runner. It's actually very, very engaging. So when people are playing this game, you can see that people don't perform well in the 2-second condition, but it takes that much engagement to get some deviation in the 5-second condition over the 8-second condition. So I guess the takeaways here, people are very good, but having people engage in passive secondary tasks isn't that different than having them supervise the ADAS, but active secondary tasks could be challenging because people have to switch out of the mental space. So those are the kinds of things I just want to show you that we're doing in the controlled experiment space. And I think methodologically, I think the results are really interesting, but methodologically, that's actually really close to what people who are doing human factors experiments in automotive are doing. One thing that we get asked all the time, though, is we have a very high hit rate. We have some really interesting results. And I think the secret sauce in our research is that we are actually just doing these experiments not as fishing fishing expeditions, but really to confirm things that we're learning when we're doing more open-ended design experiments, that where we already know what the range of behaviors are, and then we're able to just run a controlled study to verify it. And so a lot of what we're doing now, what I'm going to show you now, is kind of what we're doing as more of our secret sauce kind of design methodology stuff. So one of the things that we're really interested in this theater of cars, just really understanding how people are going to behave, respond, and feel. And part of the way we do that is just by having video trained on the people. And that sounds radical, but we talk to all sorts of people who are in the automotive space, and they have done experiments for many years, and they're just not looking at videos of what is happening to the driver. So I showed you that unstructured transition before, and this is video of one of my students pilot testing that study. So one of the things is that basically having an orientation where you care about the user experience means that you're more attuned to things that are going on and more likely to unearth things that matter. This kind of video, which you see all the time in our interaction experiments, really led to us doing some research looking at whether we can detect how people are responding emotionally to the in-car interaction. So, for example, this is research where this shows a screen of that same video that I just showed you being run through the iMotion's emotion facet software. So it does coding. It used computer vision to do facial action coding, looking at like how people have forehead and like mouth and like eyes wrinkle up, and then it uses that to guess and predict whether people are feeling joy, anger, surprise, fear, and contempt. And one of the things that you can see here is that where that red line is kind of the moment when he was having that holy shit moment. And the emotion recognition software here says that people feel like joy, like a high degree of joy, anger, and contempt. The main thing I'm showing is not that good. This software is trained on people talking to other people, and it doesn't actually do that well, like guessing at emotional reactions of people who are engaged in driving, partly because there's affect flattening when you're engaged in the task of driving, but also, I mean, I think you're not actually socially emoting. And one of the things that this has led to is actually us doing some research where we're collecting data about how drivers are reacting emotionally in the cars and working with machine learning people to develop models for emotion that are actually more appropriate for cars. I mean, one thing is just the sorts of things that matter in social interaction might be really different from what happens in the car. Like you care about whether people are stressed, if they're feeling busy or rushed, you know, and those might be the things that better predict the things you care about, like whether people are going to do a good job taking over, than whether they're feeling a lot of joy. Joy is not usually a thing that you feel a lot of when you're driving. So basically I'm saying we're using the driving simulator, but because we're really attuned to the experience, we're also measuring things like emotion, which is a little bit unusual in the automotive space. And we're also doing some research looking at physiological response. In this case, we actually have a car in autonomous driving mode, and then the car is basically changing lanes, and we're using F-nears to see if we can see people predicting when the car is going to do something. One of the things that's really important when we're thinking about the possibility of people intervening in autonomous driving is the degree to which we actually see people recognizing situations that the car might not recognize. So one thing we can do is like maybe instrument things to see when people notice stuff. And I've learned a lot of things recently. I don't know if some of you actually do biosensing. We actually have to set up these pretty contrived experiments. If you actually put like a sign on the side of the road, it will actually introduce all sorts of noise to your F-nears experiment and will throw everything to heck. You know, you actually have to do that lane change 8 times and average it, because each time is actually super noisy. Every time they move a little, it's noisy. But if you average 8 times, you can get something. So it's like one of these things, it's an interesting learning curve. And when we're in the simulator, we can see things and see how they correlate with other things. So you can't actually use F-nears in a real car, but you can use this measurement to understand what things people might predict or not, and then do those other experiments in other situations. And kind of in this theme of thinking about measurement instrumentation in simulation, we can try to develop measures that we can run both in the simulator and out in the real world, and see how well experiments that we're running in the simulator are going to correspond with behaviors we're going to see out on the actual world. And so what I'm going to show you here is something that we're using to measure situational awareness in autonomous vehicles. It's a tool that's called DAZE. It's made by David Sirkin, and it's our version of Waze. And we basically, by asking drivers about what's going on the road, we can see how much they're aware of what's going on. Oh, please play. Oh. And something I've mentioned to some people when I was talking to you in the interview today, a lot of our work is done in collaboration with people from industry, and one of the things that they're really interested in is these like research methods and like measurement methods. So very often, people at Toyota and Ford are developing cool interfaces and interventions they don't want to share with us for IP reasons, but they're very interested in working with us on what is the right way to measure differences between this situation and that situation, and like see if drivers are more or less aware. So we can kind of collaborate on understanding drivers, and then the actual like IP innovations in the car, like that they can work on themselves. So there's like a really interesting role for the designer to help understand the situation better without actually having to be involved in the design of the actual technology. So I think one of the things that we're trying to do is always actually actively engaging this theater metaphor and thinking about how we can use theater to push the boundaries of what we can discover. One of the things that I'm very proud of is this kind of use of Wizard of Oz improvisation in a driving simulator setup to understand things that other people just wouldn't see. So Wizard of Oz, for those of you who don't know, is a technique that's often been used in it's actually started in speech interaction, when people were developing speech interaction things where the actual comprehension on the part of the machine was not that good. They would actually put people, behind the screen acting like the speech interface, and then discovering how the interaction and conversation would happen and using that to help design things. So Wizard of Oz is very popular with designers because we can actually use it to understand how people are going to interact with the technology before the technology is present. So in that driving simulator that we do some experiments where behind the screen, in situations where we have autonomous driving, instead of actually having the computer control the car, which we can definitely do, we have a person that's behind the screen that can actually act on behalf of the car. So they're basically seeing what's going on the road, and they can actually take over driving. And that lets us do things like watch the video and see when someone's distracted and do something stupid, And so it's not a controlled experiment, but is actually kind of much more ecologically valid. We can also do things where we watch the way that the driver drives and then drive in the same way, or do a different driving style and see how that affects how the driver feels. And we also have then, in addition to the driving wizard, an interaction wizard. And so that's a person who's sitting behind the screen, watching what's going on, seeing what's going on the dashboard. And that person's in control of a text-to-speech generation system, so they can watch what's going on and then ask people about how the drive is going in real time. And that allows us to understand at a much deeper level what the experience is like. Then you can understand if you have people do a whole experiment, then you ask them about the experience, the whole experience after the fact. So here's an example of what that looks like. So what happened there is something that's familiar to all of us that you do texting conversations with other people, but something you normally don't see happen in speech, which is that the person who is the wizard is queuing up a response, but there's some latency, and so by the time they actually say something, it's in response to something that just got said, and it's like not quite right. And you can see there's some confusion on the part of the driver. And then this is the interesting thing, like the facial response when there's a misunderstanding is a smile. but it's a particularly awkward kind of smile. And that person says like, and then in this case, the wizard kind of followed up with the right response to the last interaction. The other thing that's happening in this video, which is a little subtle, but when we actually transition from manual driving to autonomous driving, that's actually a point of like some concern for people. A lot of times people are told something is going to transition, we've changed the icon, and people are still like hovering with their hands. Well, we actually seen in like on-road studies, people are like, I totally trust the car. Yeah, the Tesla's amazing, you know. So people actually need many, many, many reassurances that the car has control, you know, of the in that transition from manual to automatic. What we found is that if you run studies where you force people to transition, they transition. But if you give people the option, if that transition experience is poor, people won't do it. So all this concern about autonomous cars, if they design those things poorly, people will never use them. But that's an interesting thing. That's something that people don't think about. People are very concerned about the other thing. And so this kind of experiment lets us like examine like, oh, how many different things do we have to do? What kinds of transitions work? One thing that's interesting is people expect a transition to cause some sort of discontinuity in the driving. They want it to be smooth, but if it is really smooth, people don't feel like it's transitioned. So you have to do something that is both smooth and different, which is pretty challenging from a controls perspective. Another thing that we've been doing is taking this driving simulation setup we have and moving it onto the road. One of the reasons why we want to do this is because it's actually very difficult to simulate many of the things that we care a lot about. I joke about this, but like it actually takes like a week, for example, to program a traffic jam in a simulator, because you have to put in each one of the cars, and they have interactions with all the other cars. And meanwhile, every single day of the week in the Bay Area, you can find a traffic jam, no problem. So one of the things that we've done is like develop something so we can instrument the inside of a car just the way that we've instrumented the driving simulator and see everything that the driver is going through, the study participant. And then we set up something that's very much like our in-lab Wizard of Improv situation, where we have both a driving wizard, and in this case, it's a person behind a partition who's driving the car. And they're trained to drive as smoothly and carefully as possible. They have an set route, but they drive like a robot. And then we have a person who's an interaction wizard, controlling the interaction with the study participant. In this particular picture, we were actually doing something that did haptic pre-cueing, so doing haptic cues to let the person who's the driver know what's coming up and seeing if that helped to alleviate some of the motion sickness that happens if you're not watching what the car is about to do. And also seeing if that affects people's sense of situation awareness and trust in the car. So in this experiment, the interaction wizard is looking over the shoulder of the driving wizard, seeing what's coming up, and then signaling with different kinds of haptic and pneumatic interfaces things to the participant driver. And so here's video from some of these runs of this, we call it RADS, Real Road Autonomous Driving Simulation System.
How did that go?
Oh, it's pretty amazing.
Go, Otto.
I guess the computer is pretty cautious, which is pretty awesome. The number of obstacles that I could imagine being almost for a computer car, it's that we have a lot of people on the side of the road on this really small street, like construction and like traffic and all these different situations where it's basically doing the right thing. Yeah, it's much better driving.
So how did the ride go with Stanford Touch?
I was impressed. It went very well.
Did you feel nervous at any time?
I did. There was a construction site that we went past. There was a construction vehicle, and the guy was waving for me to move. So I sat there like a retard. I was staring at the thing. I didn't wave to the guy or anything. So I was like, I really hope the car does smart. So the car backed up, and then the guy made more hand signals.
Did you trust the vehicle?
I just don't fully trust that car to drive on its own. Even though I had no bad experience with this car, it just seems strange to me still that car can drive itself.
We will now turn on the autonomous control, and the car will now be parked. Please say hello. Did you notice the car say hello?
I did.
What was it like?
It was an engine roar.
Okay. Did it make you feel uncomfortable? Great.
No, I thought it was very friendly.
Was it very bad?
What I meant, it was smooth, cautious, but normal driving experience, kind of what makes it cool. I think I was surprised how much I trusted it. Even from the beginning when it said hello, that one thing, I gave it enough personality to really trust it. It made me feel like even though it wasn't a human, it wasn't of malicious intent. It just was driving carefully, slowly. Actually, it reminded me of like driving school instructor.
Was this pattern of driving okay with you?
No, it was ideal. I could definitely own these. How do I find reading in 10 years?
So this footage is from, from this thing where we were testing out these different interfaces. And the interfaces didn't end up making that much of a difference. But when we realized actually this simulation platform actually works so well in a way that we didn't expect. Like, for example, we didn't file this as a deception study because we really never meant for it to be a deception study. I mean, we maintain for theater, a partition so you're not looking at the driver, but there is actually on the consent form a statement that you're always being driven by a licensed human driver. But a lot of people said, they know there's deception sometimes, and they just figured that was a deception. And the main thing is that it felt real to them. And so the things that you're seeing them go through is actually, is similar to what you can actually expect to happen on the road. And so, for example, one thing that's really interesting is people feel responsibility when they're sitting in the driver's seat. And I will say there's a steering wheel in front of them, but it's just taped on against theater, right? But they feel responsible for the car. And this woman who came upon the construction site, you could hear in her voice real stress, even as she's being interviewed about this afterwards, about the fact that she felt responsible for moving the car and being a cooperative road citizen, but didn't have any control, and that's something that people are going to feel. It's like this responsibility and lack of control, and really thinking about how we negotiate things like that is going to be really important to get people to want to do automation. Yeah?
Have you done any studies with non-drivers? So like, even when I'm a passenger, I feel like I'm supposed to be in control of the car if I'm like a terrible passenger.
Exactly.
But like, I wonder, like non-drivers wouldn't have that sense.
Yeah, not yet.
Yeah.
But one of the things is that if you do experiments in the Bay Area, it's actually decently difficult to recruit non-drivers. But I have friends at Cornell Tech, who are in New York City, and there's whole populations of people who haven't driven. So yeah, that's something I would like to do very much. And I think it might very much be different. Those of you who need to leave will miss out on this really cool video. So one of the things that we're really interested in too is how people who are outside the car are going to interact with autonomous cars, because those people presumably wouldn't have signed up, to buy an autonomous car, use an autonomous car, but they're still going to be affected by the fact that there are autonomous cars on the road. And so this is a field study looking at how pedestrians and driverless vehicles interact. And in this case, most of the stuff we're doing is autonomous cars. There's still a driver, even if that person's not always driving. And in this experiment, we actually have, it looked like there's no one behind the wheel by putting a person in a car seat costume. I will admit that in some ways, the study is disappointing because we were kind of hoping people would be falling down upset or what's going on when they saw driverless cars. But you can see that everyone's very cool, oh yeah, now this is happening. One thing that is interesting is that when we first started running the study, so we ran it for over the course of a week at noon, because that's when there was the most traffic in this place that we scouted out on the Stanford campus. And the very first day, we have a person who's walkie-talking, and then the car basically pulls up so they can kind of show up at the intersection at the same time as pedestrian. And then after the pedestrian crosses in front of the car, then we chase them down, and the grad student chases them down and interviews them. And a lot of the people that we talked to didn't remember passing a car. Not that they didn't remember passing an autonomous car, they didn't remember seeing a car, and this includes people who were waving at the car, looking at the car. Afterwards, we're reviewing the footage, she saw the car, And we thought maybe they're so busy, they just needed to get going, needed to pretend that they didn't see the car. But after enough people did it, we're oh my God, people don't remember passing a car. And what is going on is that on-street interaction is so automatic that people can do it without consciously processing any of it. They can just interact with all these different people and cars and not think about it. The second day, we basically performed a breaching experiment. Once people entered the crosswalk, we moved the car a little bit and then stopped. I want to emphasize there was a licensed human driver actually driving in the car, and the people were not actually in danger. But in that case, people look up, And then they see there's like no one to negotiate with. And then interestingly, most people continue to walk across in front of the car. They stop, and then they just continue. And when we ask people, they're like, well, I think that if I'm really clearly walking, the car will do the right thing, which is a huge assumption. But that is the assumption. There's kind of like a social contract. So that thing that you saw one person kind of like change their mind and walk around the car, that was very rare. One thing that we noticed is that people we would ask them, did you think it was an autonomous car? And most people did. It was like 80%. But people would say things like, yeah, I thought it was a bad driver, but then I saw it was an autonomous car. It did a good job. So it's interesting. There's some like expectations that are different. And that kind of comment really made us wonder, like, how much is this behavior that we're seeing like universal, and how much of it is it like because we're running this on the Stanford campus and people are like very pro technology and like yay autonomous cars. So we've actually been running this experiment other places. We've done last summer we actually ran this experiment at University of Twente, where one of my students who was running this thing is now a professor. And then last fall we actually ran the same experiment in Mexico. And when we actually see similar behaviors of the people in the Netherlands, we're much more like, this is not normal. I don't expect to see an autonomous car. They're much more likely to stop in the middle of the road right in front of the car and pull out a phone and start filming. But one of the interesting things is one of the reasons why they're filming, and when we were interviewing them after the fact, is that their expectation is that if something like an autonomous car was going to be introduced to the public roadway, is that they would have been asked permission, and they, as a society, would have decided together that they would, want automation and how it should interact. And that is not something we ever heard from people in the US, and it is not something that we heard from any of the people in Mexico. So this has to do with how people interact with their government and their expectations of, the state and the role it plays. And that actually matters all the way down onto this pedestrian car interaction. So I think there's some really interesting things to do in this space in the future, and it actually pertains a lot to policy, and I think it's really interesting. So wrapping up, I think one of the things I'm very excited about is just thinking about how theater has the power to give us these kind of windows into alternative futures that we might have. And also, when we're doing these interesting, weird experiments about things that might be, how often we're surprised with little insights about why things are the way they are actually right now. That's always something we're like, did you know that you don't really look at the drivers of other cars? I thought we tell each other all the time, we make eye contact. It turns out not to be the case. So there's all these interesting things that we discover about our everyday interactions and how things really work as we're doing this kind of experiment. Just for fun, I'm going to show you this little piece where the robot research and the car research come back together. This is footage from my student Brian Mox's Ph.D. thesis. He has a robot steering wheel. It turns out this makes people much clearer on who's in charge of driving the car.
Automation off.
And people are much faster to take over when they see that thing come out at them. I will also mention, of course, I think it's obvious, but just that this research, not research I'm just doing by myself. This is research I'm doing with my wonderful students and sometimes visiting researchers at Stanford. And one of the things that's really important to notice is it's a multidisciplinary group. I'm actually in mechanical engineering, so many of the students are mechanical engineering students, but even the mechanical engineers have weird backgrounds. We also have people that I'm working with that I've recruited from CCA, people from the School of Education, people from communication. So it's one of those things I really enjoy about the research we're doing. We also work with corporate partners, so the stuff is actually informed by things that we're learning about technology and issues from the automotive industry. And I want to say thanks. Yeah. Yeah, we're taking questions. Sorry, I just missed explicit. We're just taking questions.
Thank you for your talk.
Thanks.
I love the metaphor of the theater. And so my question is about confoundation and research and the difficulty throwing out between simulation. Maybe you had some sort of real-world validation.
Mm-hmm.
It wasn't necessarily recreate response and reaction because the driver was stopped. And so I'm wondering about how theater implies a suspension of disbelief.
Right.
Safety.
Mm-hmm.
And then again, the knowledge that they're being watched,
Yeah. Yeah, I mean, I think in design, we basically do variations of simulations all the time. Like just imagine this is a kitchen and the whole thing's made of foam core. And so kind of this fidelity issue is not always like super. I think we as designers in our practice kind of come to feel that works okay, but we get these like little insights. For example, in this like RADS setup where we mean for it just to be a suspension of disbelief, protocol, and then you find out that people, really think that they're in Tana's car, and you see really similar behaviors anyway. And we, like for example, with the ghost driver thing, asked people if they thought it was Tana's car, and they're like saying yes. And so we see when we see these like little windows, usually they reaffirm that actually that people behave similarly when they're operating with suspension of disbelief as they do in real interaction. And one of the things I think that's going on is that people, I was telling someone earlier, Terry Winograd is in many ways my spiritual advisor, and he's a phenomenologist, and I think that the way that we interact with machines when we're confronted with a new situation is very much decided in the moment. It's kind of co-constructed. And so even if you, when you're confronted with these like a robot trash barrel, you're not sitting there asking like, is this an experiment? Like, how does the thing work? What does this thing see? Like, they're very much like kind of acting in the moment, like, okay, like, and it's surprising, but it's actually been true over and over, that people just like engage with things as they are and then are not asking the deep theory of mind questions. They just play along like they're in a theater. And I think it means when we interact with one another on some level, it goes back to the AI people, we just give each other the benefit of the doubt. We don't really know what's going on in each other's minds, but we know how to interact anyway. And so I think that's part of what's going on. Because what we're trying to do is do design, and this isn't the last stop, and we're not using this to like make generalizations about human behavior for scientific reasons, but trying to get insights into how we should design things for design reasons, and eventually down the line there'll be some like real thing that then gets tested. I think we are a little bit less concerned about whether this stuff is true and more concerned about whether this stuff is like useful or like is likely. So I think the standard of proof for something as a design research experiment is slightly different than if what you're trying to do is something that's just like, this is how it is, guys.
Thanks for the really interesting talk. I had a question about your very first demonstration with the ottomans and the garbage pails that people were sort of treating like dogs, or some people said they didn't want to put their feet up on the ottomans because they didn't want to be disrespectful of the dogs.
Yeah.
But on the other hand, as robots become more pervasive and people do start treating them like dogs or slaves or that sort of thing, what do you see about the increasing automation and people, they're feeling the automation being more and more anthropomorphic, and then people nonetheless treating them more and more as they're doing their bidding? Do you see there's already, Sherry Turkle talks about a decline in empathy. Could you pontificate on that thought?
Yeah. So I do not know if I totally believe in what Sherry's saying about the decline in empathy. I haven't seen actually the evidence that makes me feel like yes, I think that something's going on. But I will say the kinds of experiments we're running don't give us deep insight into that, because the kinds of experiments that we're able to run right now are sort of one-shot experiments. We only get to see what people see and do and feel right in the moment of the first encounter of this new technology. And one of the things I'm really interested in working on is doing things where we can revisit the same situation, like have people see the same ottoman like a day, a week, and a month later, and seeing how those things evolve over time. And I think that will be instructive. But I think the state of the art in terms of methodology isn't there for that. Like in the human-robot interaction space, we only have experiments where people do these one-shot experiments, or you have something like Corey Kidd from Cynthia Brazil's work, where they make a real working like dietary, like compliance robot, and then like they have that deployed for 6 months and like watch that. We don't have some like good lightweight ways to understand how these expectations and things will change over time. One thing that's really interesting, I think is promising for looking at that kind of question is the cross-cultural research, because, for example, there are really different attitudes about servitude in different cultures. one of the women that we worked with when we were workshopping the Ottoman behaviors is a dancer named Alita Hayes. She's a choreographer that teaches at Stanford. She's African American. And at one point we were like bringing this Ottoman in and then having it sidle down and like set itself down. And she said, oh, now we're in India. And she was explaining that when, as an African American woman, when she went to India, it was really weird because service is really deeply caught up with slavery in the US. And so we are in some ways very overt and like super polite about the way that we handle our interactions with people who are service, people in the US. But in India, kind of seamless service is like this art form, and for her it was like this revelation that could be very different than the way that it happens here. And as she was discussing this, like I just felt my students, like these mechanical engineers, like people from Caltech, they were like so uncomfortable. They were like trying to like move out of the room. And like I remember Brian Mock saying like, I was told never to talk about stuff like that, and so here's a really interesting thing, like when we interact with the Ottoman, we interact as Americans who have a history with like slavery, and then when this thing does something for us, all the ways we react actually, involve that. And there are other cultures where they have a different feeling about service, and servitude, and those people might interact with the machines really differently. And I think it's possible that we can actually borrow some of the interaction patterns and attitudes from other cultures and think of them as how those things can be invoked and prototyped here. So one of the ways that we can look at the ways things can be different is by looking at these same experiments but in different cultures and thinking about like what is going into that and how can we invoke some of those things that make people look at things a certain way here. But these are just like huge open topics, like how to deal with culture in design, and I think something I'm really excited about and don't have answers to completely yet. Yeah.
Well, it was really fascinating talk. Thank you so much for this. I'm curious if you can say something about the difference between how we interact with technology in the very early days versus maybe even like a year or multiple years later. While you were talking, I thought of some examples of some technologies like cell phones and internet search and maybe even Google Glass, where the early adopters sort of had one sort of vision of how we would interact with them, and that seems to have changed quite markedly in sort of just a year to 2 years after they became commonplace. And is sort of looking at Ottomans coming up, are we sort of investigating people's first looks at a technology, and is there any ability to look past that and maybe make predictions about how it might go, how it might fare in the longer run, or how can we approach that?
Yeah. I don't think that the kinds of experiments they're running here are great predictors of like long-term behavior. I mean, for example, what the goal of the Ottoman was really about whether you can express intent for engagement and disengagement using nothing but motion alone. Most of the people working in the robot space are using things like sound or like putting anthropomorphic features like eyes on things and then saying like, look, people humanize the technology. And it's like, oh, but I don't even think you need that much. I think motion alone will invoke, anthropomorphic behaviors. And so that's kind of what we're showing. And I think that something like that would persist, I don't think that people would treat it and like understand that engagement and then later on go like, what's going on? But I do think that interaction patterns change over time, and something like acceptance and some of the cultural and interaction patterns that develop around an object are really difficult to know just at this first pass. One thing I'm really obsessed about is like kind of history of technology and looking at how people interact with things, and then trying to understand how those things get created. I often think that people assume that the way that we interact or culturally accept a technology is inherent to the technology, but I think it has everything to do with the way that it's rolled out and like what we use as metaphors and and framings when we roll them out. And so as a designer, I think a lot of these things are malleable, and I'm interested in how we shaped that. Yes, Anna.
I also enjoyed the talk very much. So can you give an example of how this fascinating research might shape the design some features of the design of an autonomous car?
Yeah, I mean, one of the things that I think is going to be really important in the car is that the car is going to have to actively monitor and manage a person's attention. So when people hear that we work on autonomous vehicles, people in the research space usually say, oh, we used to do a bunch of work in flight automation. You should be able to learn from that. And one of the crazy things is that in flight automation, they never ever tried to solve the problem of automation, where like vigilance is a huge problem. It's really hard to keep people awake. They never tried to solve it with design. They always solved it by like training people, to do different things or accomplish different tasks, or giving them housekeeping tasks to keep themselves awake. We never tried to do anything where the plane acts differently to keep people awake. And I think, for example, that like you can train all these pilots because there's not that many pilots, but we're not going to be able to do that with drivers. There's so many of them, and they're so different. And so the car will actually have to actively manage, just the way, if you are arrested for drunk driving, you might actually have something that checks to make sure you're sober before you're allowed to drive. We're going to have, I think it's going to be important to have cars that are monitoring people to understand if they're alert and where their attention is. And I think one of the really interesting things is that I think that the car manufacturers are more interested in that question of how you interact with people than they are in actually in cars that can pilot themselves down the road. Because a lot of their interest in autonomous vehicles is actually not about making a car that can drive itself down the road, but competing with Apple and Google for the attention of the driver. So they're much more interested in, can I do something that like helps people find their favorite radio station, or like involves them in a game, or helps them go shopping, while they're driving, than, like actually moving the car down the road and avoiding hitting things. So I feel like a lot of the things that we don't understand about what the car companies are doing in the space actually have to do with the fact that when Apple and Google entered the mobile space, they like took everyone out. So the car companies don't want that to happen to them. And so now they're much more interested in the user. So these kinds of experiments help us like understand how to manage that attention and like what sorts of features people would be interested in.
Again, a great talk. One thing that struck me about the experiments, and often about how people think in terms both of design and interaction, is in some ways in highly individualistic terms. I mean, the question you got, I thought, was a very important one about what happens if there's a passenger behind you. Yeah. Because they're often the person who turns and says, wake up, and why they're saying wake up. Also, notions of obligations to other drivers. Mm-hmm. If the simulated drivers have no eye contact, no interaction, and all those, terrible philosophical ideas, would you sacrifice your own life to save the 5 children in the other car or whatever? And I just wondered if you felt there was a way in which to start thinking in more social terms about these things rather than individual, as the experiments seem to me to be.
Yeah, I mean, yes. I think one of the things that we're doing is basically trying to push the frontiers of a certain research paradigm forward. And so, there are existing paradigms for doing controlled user experiments with a driver. And so we try to push it on that a little bit, do uncontrolled, user experiments with a driver. One of the things that we also do, though, is much more of these workshop-y things where we stage, different ideas for the future. And some of those things we actually do work out scenarios, or what does this feel like when there's 2 people? What happens? I got this one really wonderful grant from MediaX to look at legacies in the States. So MediaX is this on-campus consortium. And so we actually instrumented in-car experiences, and we captured, for example, with the way that we captured these research things, we captured a woman with her daughter learning to drive, and just look at that experience. We captured an experience where we had Barry Cates, who wrote this wonderful book on Silicon Valley design, driving to different places and just talking about different places, running a tour. We did do one experiment. We had mom, dad, and a daughter in back, and so we're not in the car with them, but we're recording what's going on and looking at what some of those interactions are. So those are just one, we capture a drive, maybe it's an hour-long drive, and we're looking at those things. So, and And one thing I'm really excited about, we did one instrumentation where we outfitted a car where there were 4 people driving on a road trip from San Francisco to Portland. And we captured, we were able to kind of do Wizard of Oz interactions periodically when the cell phone access is good. And like, you know, like people would ask questions about things that were in the environment, like what's that mountain? And the person who was, you know, kind of the wizard and had a camera was like looking at the GPS location and going like, that's Mount Shasta, you know? And then all, you know, like weird things that come up as conversational topics when you're on a road trip with 3 of your friends, like they were able to like insert like trivia and data. So I think we are pushing on that, but that's on that more like designerly investigation, need finding end of the research, and less the controlled, you know, experimental, like more confirming things. And I think we're always trying to think like, what is the right thing to design that would really speak to the situation? You know, and sometimes we're still just trying to understand the situations. There's nothing to design yet, but we are watching, you know.
One last question. Can you talk about what's next? Expanding this automotive space or other autonomous systems interactions that you could perhaps give us a preview about?
Yeah, so in terms of what's next in the car space, I mean, a lot of the work that we're doing here is about understanding users, and then I'm thinking about things that are elements of interaction that we can actually like test. So one element of interaction is knowing when to start. You know, like when are we allowed to talk to each other? And it turns out for in-car interaction, this is like not a trivial thing, because if you interrupt a person at the wrong time, you can cause them to have an accident. So we have an experiment that is called like, Is Now a Good Time? And we just are collecting data about like what the GPS data is, what's happening in the cabin, what's happening outside the car, what the IMU, you know, like are you accelerating or slowing down? And we're collecting this data corpus, and then in the meantime asking people, is now a good time? And then they say yes or no. And we're trying to see how well can we actually predict when are good times just to start a conversation. And so, you know, that is an example of one thing. There's other things like looking at real-time repair. So like if I start to say something wrong and you make a weird face, I'm like, oh, can you ask that again? You know? So just detecting when that people make that face that indicates to another person that you need to perform repair. So we're basically trying to do a bunch of things that are these like elements of interaction that we think will be, later on you'll be able to string together to kind of make a real interaction happen, and developing data corpuses and doing real recognition to enable that. So that is kind of one part of what we're doing, just trying to take steps towards real autonomous, we call it closed loop interaction, where there's actual back and forth. Another thing we're really interested in are these cross-cultural differences, which will become really important when we have automation, because I think a lot of people who are in engineering, computer science, tend to think like, once we have automation, we'll do the same thing everywhere. But actually, if you look at interaction, it's incredibly contextual and culturally dependent. And what you actually want is to understand these important nuances and differences between cultures and do the right thing for each situation. And that's going to be a terribly hard thing to explain to a machine, you know. And so just trying to do the experiment so that we understand more systematically these things that we qualitatively definitely know, like the fact that if you drive here, it's different than driving in the city or in Boston or in India. We know this, but exactly how do you translate that to like what's the right headway distance to do? Like if you are merging, what is the merging behavior? Like these are things that we actually don't have numerical algorithmic answers to. So I think doing like cross-cultural research to understand differences in people. And then I am really interested in the robot space, looking at multiple people, multiple autonomous agents, and understanding more the kind of sociology of interaction with automation. So it's not always just like one person to like one machine, but in normal everyday interaction, we have interactions with all these different people and all these different objects, and thinking about what that's going to be like. So I'm doing some work with robot chairs that can reconfigure themselves, but the questions really have to do with, if you have a bunch of chairs that can rearrange themselves, how can they move in a way that's not threatening, and how do they move in a way that's predictable and understandable, and what are the expectations to do socially appropriate motion that way?